Okay, here we go. Here's some information about crime. Now, here's the population down here. No, so these cities are fairly close in size. I'm interested in the murder rate. Now, from what I understand, when people investigate a murder, many times when they solve the murder, it's because the person murdered knew the person who killed them. Okay, let's go with that. Now, with robberies, a lot of times when a robbery goes really bad, somebody gets killed. Okay, I'm going to keep going with that and say, well, is there a connection between an increase in murder rate and an increase in robbery rate? Maybe. Let's look at these numbers. Now I'm going to really focus on some kind of tight data here in the 5. So in other words, if the murder rate goes up by just like a tenth, does that affect the robbery rate as well, and how closely? Okay, there we go. There's the setup. Now I'm going to throw that data into, or some of this data, I don't know if I'm going to put all of that stuff in, but right in here, put that data into the calculator and get a least squared regression line. Okay, here we go. So I put 8 data points in there. You can't see all of them, but here's a section of them. And just put those in. So our explanatory variable is our murder rate, and our response variable is robberies. Do murders explain how many robberies we have? Okay, let's go with that. Now we go to calculate our linear regression. Things do not look good. Now look at this. Well, here's our slope, and here's our y-intercept. And what does this slope mean? What is the meaning of this slope? What it means is, for every murder, so for every one murder that happens, we should have 38 more robberies. That's the rate. Okay. Now, what about the R value, our correlation? It's not very good. Okay. Remember, 75 and above is adequate. And then once we get into the 80s and 90s, that's really good. So this is not that great, not closely related. And our R squared, we better write that sentence about the data. So this is our coefficient of determination. Okay, let's take a look at that. Okay, here's that sentence we should say about coefficient of determination, the R squared. 21% of the variation of robberies is accounted for by our regression line. Okay. And I was saying in class our data, but I think it's better, in fact I looked in the book, if we use our output variable, our response variable, instead of data. 21% of the variation of our robberies, that's our response variable, is accounted for by the regression line. Okay, there's that. So I think it's helpful if we use the variables that we're talking about in our regression line. Now I kind of cheated, and so this is robberies, this is our murder rate. Okay, so for one increased murder, right, that's going to increase our robberies by 38.3. Now if they asked you to predict, okay, so if you predict that how many robberies are going to occur if there are 6 murders during that year. Okay, so let's do that. So this is a prediction. So if I plug in 6, I crank out the numbers, our prediction is, based on our least squared regression line, 156.6 murders. So remember, that's a prediction, y hat. Okay, now our data, it turns out, looks not that great, because look. So here's our least squared regression line. Notice that, let's see, this is the same right here. This is the same exact murder rate, but our crime rate, robberies, is high and low for the same exact murder rate. So that's not great. But this is what I want to talk about. I want to talk about the residuals. Okay, let's do that. Okay, so the residual is our actual value compared to our predicted value. So let's take this point right here, 5.8, which is right here. So looks like it's quite a bit lower than what we would predict. So what is our predicted value for 5.8? Well, we plug it into the equation. So here we go. We plug 5.8 into our equation right here, and that would tell us where we are up here on the line. So what is our predicted value for 5.8 murders? How many crimes should occur? That's our prediction. So our prediction is 148.9 robberies. Now that would be right here on the graph, right there. But look at what the actual data was. It was much lower than that. So what we can do is we can subtract them. So our actual number was 140.8, 140, whoops, 0.8 minus our predicted value, which is 148.94. And if we subtract those, we get negative 8.14, which means that there was actually basically 8 less robberies than we would have predicted for that year. So that's the residual, the difference between what the actual data point says and what our prediction says. Okay, that's a residual.